Hello everyone, now we will study about range. In a group of quantitative data, there will be data with the largest value and data with the smallest value. So the definition of range is the difference between the largest data and the smallest data. Range is denoted by R. General formula of range is R x maximum min x minimum. With R is range, x maximum is smallest data value, and x minimum is greatest data value. For example, the final exam score for the C class statistics course is like this. The equation of this example is calculate the range of data. The solution, the first, we sorted the data from the smallest value to the largest value. From this data, we obtained score of x maximum is 19.8 and value of x minimum is 40. So the data range is R x maximum min x minimum. Range is 58.
The first is about variance. In statistics, variance is used to measure the distribution of data. It's measure of how far each value in the dataset deviates from the mean. As we see in the picture, we can calculate the distance for each data by the drag xi with x bar. The distance left the mean is always negative, and the right is always positive. One thing that's important to notice is that the distance must be higher than 0, so we must square the deviation. Variance is divided into two types: population variance and sample variance. Population data make 100% sure of the measure we are calculating, and a sample is an approximation of the population parameter. Population variance represented by sigma square, which is mean the sum of square difference between the observed value and the population mean divided by the total number of observation. Sample variance represented by S squared, which is mean the sum of square difference between observed sample value and the sample mean, divided by the number of sample observation minus 1. From the two formulas above, why does the divisor for the sample different from the population? To understand why dividing by n underestimates the population variance, we'll start with a few simple examples and we'll divide into the math and prove it. For example, we have a population of 5 observations: 1, 2, 3, 4, and 5. Let's find its variance. The first step, we start by calculating the mean. 1 plus 2 plus 3 plus 4 plus 5 divided by the total number of observation is 5. And the value of mean is 3. Then, we apply the formula which we just discussed. After we calculate with the formulas, the value of variance is 2. So, the population variance of the dataset is 2. But what about the sample variance? This would only be suitable if we were told that these 5 observations were a sample drawn from a population. So, let's imagine that the case. The sample mean is once again 3. The numerator is the same, but the denominator is going to be 4 instead of 5. Why is the sample variance bigger than the population variance? In the first case, we know the population. That is, we had all the data and we calculate the variance. In the second case, we were told that 1, 2, 3, 4, and 5 was a sample, drawn from a bigger population. Now, imagine that the population of the sample were the following 10 numbers: 1, 1, 1, 2, 3, 4, 5, 5, 5, and 5. Clearly the numbers are the same, but there is a concentration around the two extremes of the dataset is 1 and 5. After we calculate, the value of the mean is 3.2 and the value of variance is 2.96. So, the sample variance has rightfully corrected upwards in order to reflect the higher potential variability. This is the reason why there are different formulas for sample and population. Hello everyone, in this discussion, we are going to practice calculating the mean deviation for a given dataset. Mean deviation is the average distance of all of the elements in a dataset from the mean of the same dataset. So basically, we are trying to figure out on average how far each piece of information or each piece of data in your dataset is away from the mean of your dataset. Let's use this example to calculate the mean deviation. The following dataset represent the income of 10 residents from 2 housing complexes. Step 1 will always be to find the mean of the given dataset. To find the mean of any dataset, you have to add up all of your elements together and divide it by the total number value. The sum of 10 elements complex A and complex B is the same, that is 61. And we divide that by 10. To figure out what the mean value is, we would say the mean of the income of two complex was 6.1. After you have figured out what the mean value of your dataset is, you have to distance that each element in your dataset is away from the mean if it were on a number line. So basically, you are going to subtract each element with the mean and use the absolute value because the distance is always positive. So we have to subtract each element from our dataset from the mean value of our dataset. After you have subtracted each element in your dataset from the mean of the dataset, you have to remember to use absolute value of each difference. For example, even though 2 minus 6.1 is negative 4.1, we would say that the distance between 2 and 6.1 on a number line is 4.1 regardless of direction. So always make sure to express the difference of each element from the mean as a positive number. So next, we are going to add thus 10 distance that we came up with and divide by 10 because we have 10 numbers that we add it all together. For complex A, the mean deviation equals 3.1. We can say that the values in the dataset on the mean are a distance of 3.1 away from the mean of 6.1. While the mean deviation for complex B equals 0.94. We can say that the values in the dataset of the mean are a distance of 0.94 away from the mean of 6.1. From the table above, it is found that in complex A there is an imbalance of income for residents which is quite largely compared to complex B, with the income of residents in complex B which tend to be the same. The last of this discussion is conclusion. The first, to find the mean deviation on dataset, you can use a formula SR equals sigma of the distance between each data and the mean and dividing by total number values. With SR is mean deviation, Xi is element of data, X bar is mean, N is total number value, vertical bar is absolute value, and basically to ignore minus signs. Second conclusion, that the mean deviation indicates how spread out your dataset is. The third conclusion is a larger mean deviation indicates a dataset that is more spread out in relation to the mean, while a small mean deviation would indicate data that is less spread out and located closer to the mean.
Okay, next standard definition and quartile rings. Standard definition is a statistical value that is used to determine how the data is distributed in a sample and how close the individual data points are to the means or reference value of the sample. Standard definition formula is equal to square root 1 divided by n minus 1 sigma xe minus x bar squared. Information is standard definition, xe is data value, x bar is reference value, and is lot of data. Before using the formula, it is good to know where the origin of the formula is so that we can know the philosophy of calculation and it is. First, we first work the intellectual standard definition formula as follows. Is equal to square root 1 divided by n minus 1 sigma xe minus x bar squared. Next, understand that a minus b squared equal to a squared minus 2ab squared plus b squared, so that s equal to square root 1 divided by n minus 1 sigma xe squared minus 2 xe squared x bar plus x bar squared. By using the terms of sigma notation for the formula above can be described as follows. A is equal to square root 1 divided by n minus 1 sigma xe squared minus 2 x bar sigma xe plus n x bar 2 x is equal to square root 1 divided by n minus 1 sigma xe squared minus 2 n x bar squared plus n x bar squared, so that is equal to square root 1 divided by n minus 1 sigma xe minus n x bar squared. Standard definition function. Usually that standard definition is asked by statisticians or the people working in the world to find out if the data sample takes respond the entire population, because once the range data for a population is very difficult to do. Thus, it is necessary to assume that sample that corresponds to the interest population makes it hard to conduct research or text. Illustration is someone wants to know the weight of a boy aged 10 years in a school. That's what needs to be done is to find out the weight of some people and calculation of range and standard definition for this calculation will know that value that can respond to the interest population. How to calculation the standard definition of a single data. First, log for the range value first x bar equal to sigma x divided by L. Second, find a single standard definition. X equal to square root 1 divided by M minus 1 sigma xe minus x bar squared. Example of question and this question during term suspension consecutive semester repetition or at his beloved campus in London, Jonathan scored 92, 79, 86, 80, 75, 187, 93, 90 and 88. What is the standard definition of the test score? Answer: tables. From the calculation of the standard definition formula, the result are options for the calculation. We can see the tables above. So that is equal to sigma x equal to square root 1 divided by L minus 1 sigma xe minus x bar squared is equal to square root 1 means n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10 minus 1, 4, 5, 6.9. Quartile range. Quartile range is the across with a single quartile and a group quartile on each side. Definite formula. The quartile range formula is as follows: Jk equal to 1 divided by 2 k3 means K1 information Jk is quartile range, K1 is reference quartile or first quartile, K3 is copper quartile or third quartile. Example equation and this question determines the quartile division from the table below. Interval, frequency or Fe, cumulative frequency or Fk. Answer: to determine the quartile duration, we must first find K1, K2, K3 with the group quartile formulas because the problem is tables with the group quartile formula as follows: Kp equal to Tbp plus P divided by 4 and minus Fk divided by Fe G. Location K1 equal to 1 divided by 4 K1 equal to 52. Location K2. K2 equal to 65.5. Location K3. K3 equal to 82, so quartile rings jika equal to 1 divided to K3 minus K1 jika equal to 1 divided to 82 minus 52 equal 15.
Hello everyone, still regarding the size and distribution of a single data. We will study the following topics after quartile coverage, which is percentile range. Now, what is percentile range? Let's look at the following explanation. Previously published about percentile, which is a value that divides data into 100 equal parts. We'll now learn about the percentile opportunity. Percentile range, or abbreviated JP, is a collection of data that has the 10th percentile and 90th percentile. The rank of percentiles is obtained from the difference between the 10th and 90th percentile, which can be written as follows. JP equals PS 90 minus PS 10. Information JP equals percentile range, PS 90 equals percentile of 90, PS 10 equals percentile of 10. To better understand, let's look at an example. Single non-data 5, 7, 9, 4, 3, 4, 7, 8, 5, and 7. Determine the percentile range of the data above. Now, to answer that, remember how to find the location of the percentile with a formula. PSI equals I data times n plus 1 divided 100. With PSI equals I data percentile, n equals amount of data, and I equals 1 until 99. Okay, the first, we will to seek location of PS10. So, with input of the information, I data, percentile is 10, and amount of data is 10. So, we get location of percentile 10 is 1.1. So, we get percentile of 10 equals x1 plus 0.1 times x2 minus x1. Nah, we know x1 and x2 from the single data. x1 is 3 and x2 is 4. So we get the percentile of 10 is 3.1. Once more, 3.1. Okay. In the same way, we get percentile of 90 is 8.6, 8.9. Okay. After that, we input the value of percentile 90 and percentile 10. So, we get
the solution of percentage is 5.8. Yeah, once more, we get the percentage is 5.8. Very easy, right? With this, I believe the percentage is complete. Now, we next in the new topic is coefficient of variation. Coefficient of variation is the ratio between the standard deviation and the average value expressed in percentage. The coefficient of variance is useful for observing data variance or any data from the average calculation, in the sense that if the coefficient of variance gets smaller, the data is more uniform or homogeneous. Conversely, if the coefficient of variance is greater, the data will be more heterogeneous. The formula of coefficient variation is S divided x bar times 100%. The information is Kv equals coefficient of variation, S equals standard deviation, and x bar equals average count. Okay, we go straight to the example problem. Mr. Robert teaches statistics courses in two class A and Class B. After 8 meetings, the mid-semester examination is held. The data obtained in Class A has an average value of 75. Yeah. Okay, we get the information. In Class A, average value is 75 and standard deviation in Class A is 5.4. While in Class B, the average value is 85 and the standard deviation is 4.2. Yeah, once more, in Class B, we get information average value is 85 and standard deviation in Class B is 4.2. What is the coefficient of each security? With the information provided, it is very easy to obtain the coefficient of variation by inputting all information into the formula so that it is obtained. Now, we get the coefficient of variation Class A is 72% and coefficient variation in Class B is 4.94%. Very easy, right? Okay, well, that it's just an explanation of the coefficient of variation, and we will proceed to a more exciting topic, the coefficient of variation quartile. So don't go anymore. Don't go anywhere, everyone.
Coefficient of quartile variation. The quartile variance coefficient is used when a group of data is unknown what the mean value is calculated and the standard deviation OH. The equation of the quartile variance coefficient is KVQ equal Q3 minus Q1 divided by Q3 plus Q1. This is equation 8.1. Or by formula, KVQ equal Q3 minus Q1 divided 2 and then divided met. This equation 8.2 with KVQ equal coefficient of quartile variation Q1 is lower quartile or first quartile, Q3 is upper quartile or 3 quartile, med is median. Review. A quartile. Data groups that have been sorted and divided for equal parts are called quartiles. This quartile consists of 3 parts, namely the first quartile or Q1, the second quartile or Q2, and the third quartile Q3. So data that are not grouped or single, the quartile value is determined by the formula QE equal n plus 1 divided 4. We can see example this there. Why QE equal quartile value E, and then E is 1, 2, or 3. B. Median. The middle value of the short data group is called the median. Usually the median is abbreviated as MED. Media data is not grouped or single that can be determined immediately after the data is sorted. For n odd numbers, n equal to key plus 1, and then key equals n minus 1 divided 2. For n even number, n equal to key and then key equal n divided 2. Okay, friend, because we already know what is quartile and the median of a single data, we can easily calculate the value of the quartile coefficient of variance by using equation 8.1 or equation 8.2. Example. Find the quartile coefficient of variance for a data. Elementary statistical exam scores of 50 students of Bunga Mawar University in Northern Sumatra Utara area as follows. 16.5, 15.5, 17, 18, 17.5, 19.5, 19, 17.5, 15, 19, 15, 16, 16.5, 17.5, 18.5. Solution. Now, n or lots of data equal 50. The first thing we do is sort the data from a smaller order to lesser value. 50, 15, 15.5, 16, 16.5, 16.5, 17, 17.5, 17.5, 17.5, 18, 18.5, 19, 19, and 19.5. Then the values of Q1 and Q3 is Q1 equals value of E n plus 1 divided 4. Value of 1, 15 plus 1 divided 4 equals value of 4 and equals 16. Q3 equals value of E n minus 1 divided 4 equals value of 3, 15 plus 1 divided 4 equals value of 48 divided 4 equals value of 12 and equals 85. So by using equation 8.1, QVQ equals Q3 minus Q1 divided Q3 plus Q1. KVQ equals Q3 minus Q1 divided Q3 plus Q1 equals 18.5 minus 60 divided 18.5 plus 60 divided 25 divided 114.5 equals 0.1724137.931. However, if we want to use equation 8.2, then the first step we will do is determine the first and 3/4. The second step is determining for the median. A first quartile is 60 and 3/4 is 85. B median. To find the median, we will first determine the value of k. N equals 2k plus 1. 15 equals 2k plus 1. 2k equals 15 minus 1. And k equals 14 divided 2 equals 7. So median equals MA equals 7. MA is a value that is in the middle after the data, is in the middle after the data is sorted from the smallest to the lesser. M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, and M15. After the values of the first quartile, 3/4, and median are known, we can easily calculate the coefficient of quartile variance using equation 8.2. KVQ equals Q3 minus Q1 divided 2 and then divided median equals 18.5 minus 16 divided 2 and then divided 70 equals 25 divided 2 and divided 17 equals 12. Equals 12.5 divided 17 equals 0.17857142886.
About default value. One of the important benefits of the calculate mean value and standard deviation is that both values can be used to make data transformation that produce standard values. For example, a group of data with values x1, x2, x3 until xn has the calculate mean value x bar and the standard deviation s. We can create a default value of z by using the following transformation. The transformation is this, with zi is default value, x1 is value data group, and x bar is the average value is calculated. Because the values of variable default value are derived from the values of variable x, the z distribution generally resembles the distribution of data x. Mathematically, it can be proven that the distribution of values z1, z2, z3 until zn has an average flat equal to 0 and standard deviation equal to 1. z1, z2, z3 until zn values obtained by means of such transformation are called default values. Standard scores can be used to scale the same from two or more groups of data that were originally on a different scale, so they can be compared. Okay, we study about example. The average value of the final examination economics course in class A with 50 students is 75 and the standard deviation is 10, whereas for English courses in the class have an average value of 80 and the standard deviation is 18. If in that class, Tigor obtained a final examination score for economics is 85 and English is 92. What is Tigor's position in that class? Okay, the solution, we use formula default value. Zi is x1 min x bar divided by s, where x is the final examination value obtained by Tigor. For economics, the default value is 1, and for English, the default value is 0,67. Because the z value for economics is greater than the z value for English subjects, so Tigor's position is better in economics than English.